This video I kind of wanted to go over, um, I guess, kind of more fabrication. Fabrication to me is particularly, the kind of how I measure, how I kind of mark, or my approach to cutting, preparing and cutting steel. Fabrication. In the sense of welding, fabrication to me is the hardest part. It's the most cumbersome, um, the most time consuming. But the welding's kind of the fun part. It's it gets you to the end result. It's kind of a fun, cool process. And fabrication isn't so much, gets a lot of kind of attention, but it is the critical thing. It's almost like painting. When you go to paint, painting isn't, there's a skill to it, but overall the real critical component to having a nice paint job is the preparation of the car. It's the sanding and the filling of holes and making sure that everything's in good standing. With when you're making things out of steel, life gets easier when you're welding, because all the pieces fit together a lot better, right? Instead of having these gaps and resulting to having to grind down um, areas to get it to fit the way you want, which is an option. Um, but it's always nice when the seams kind of mate and fit real nice during your fabrication, and then welding becomes a lot easier. So, and just an example of how I do it, I'm just going to show you. I'm making some 2" by 3" braces for a customer, and I'm going. This is my first cut. They're 2 feet long, 45-degree plates at the end. Kind of traditionally to what I make sell on my Etsy site, but on a larger scale. So I've gone ahead and cut a 45 on that end, and so I'm going to measure out the 2 feet. And the way I do it is I kind of make sure. The one thing I want to point out is, and people don't kind of catch this, especially when maybe they catch it, I don't know, but when if you're measuring here, and you hook the piece of material like so and pull, versus sticking it on the inside and pushing, this end here, I don't know if you can tell, but it moves about 1/8 of an inch. And so when you're trying to go for accuracy, you're losing 1/8 of an inch if you're not cognizant of where whether your tape's pulling or pushing. In this case, it's not too big of an issue, because I'll show you why in a minute. But here, I'm hooking on the very end, and I'm doing 2 feet, right? And so what I want to get dead center on that mark. And this is one of my favorite tools, is the scribe. But I'll try to get as close as I can in the middle of that line. And make a mark. The whole concept of aim small. And then now, and the only other problem is you tend to lose it, like lose the mark. And then I'll slide this scribe to the groove that I just made and stop it there, and then I'll butt up my my speed square. You may be able to see it in the video, but there's a scribe right there. It's just kind of a light mark within the material itself. So the next thing I do on the left side of this line, bring this down like so, and I'm going to try to align the best I can, is to put this shiny metal tooth, actual cutting teeth, just on the outside edge of that mark, so that this is exactly 2 feet. The other component, or the other thing you want to keep in consideration, is to make sure that everything is level from the back side and the bottom. Sometimes tightening up your saw will shift your mark, so double check that every time, like a couple times, and then make sure that you kind of get to know your saw, like make sure that this is, I put a speed square on here to make sure that this was at 45 degrees, because even though it has a mark here, I mean, it's you really kind of want to put something on there to double check it. And then also making sure that the back is level, right? So I've shimmed up some wood here and there. So the next part is the cutting. So let's get that mark, tighten up. Here you can see the attempted cut, and where the line meets with the cut is getting your kerf here, and making sure you get as close as possible. Don't forget to flip your piece, because it's just part of the project in this case. So going back to sometimes I'll put magnets here at the end to kind of level them up. Put one on the bottom and overlap it. But the closest you can get, the better off you'll be. And there you have it. You start your next line, your next cut. It's a little awkward for me now because I'm working with a 12-foot piece, but once it starts getting shorter, it gets easier and easier to work with. But that there again, want to mark. You want to take this. I'm going to take this saw blade, take the tooth of the saw blade, put the very outer edge of it as close as you can. I mean, I almost make it kind of a game to kind of make it right on the exact spot there. This one doesn't have a laser on it. Also, I certainly recommend the Metal Devil. It's probably been one of my best and favorite tools to use. It's unbelievable to me, as well as it's worked for me. And I cut a fairly good amount of metal. This is 14 gauge. I mean, you can see it kind of struggles a little bit, but that's because I've had this blade on there for a little bit, and I've cut some other heavy duty stuff. But overall, it's great. The blades are expensive. I found the Diablos for about $67. The one that came with it, that exact replacement, is about $100, at least when I bought it. And then, but this one's around 60, 70, and it works just as well. They work about the same, I think. And then the other last thing about it is sometimes when your saw's starting to get old, it'll have some play and it'll mess with your cuts a little bit. And so, like I was trying to emphasize earlier, you really, really want to go as far as you can and make sure that you cut as precise as possible. That's kind of why I got the plasma table, because one, it makes life easier, and it's way more accurate than I can be, at least on a consistent level. So now that you've seen that I've kind of cut all these here. They're all within really close tolerances within size. Now that I've cut these 2x3 square rectangular tubing into 2 feet lengths, before I weld the plates on that I still need to make, I'm going to clean up these edges, and with a used flap disc, I'll come, knock all this loose stuff off, and then I'll go at a 45 all the way around the edge, so that I create a kind of a small bevel, and that way when I have this plate up against there, when I'm welding it, I'll have room for more of the weld to kind of get in between these two pieces, and then as the heat dissipates, it should give you a better weld there versus just putting it on the surface of 2 pieces on the flat side. As if you end up needing to grind that down, you could take away that weld depending on how much penetration got down in there. But with the bevel, it kind of gives me a little bit more assurance that I'm actually getting weld in between there and deep enough so that if I do grind it down, depends on the aesthetics or the need. Industrial ones you don't try to make look nice, and then ones for homes or shelves and things like that, you might make them a little nicer. But this way when you weld it around, you have better chances of having molten weld down into here. So I'll show you this here now. And here's what the end result looks like. This is as far as you need to go to prepare it for welding up. In the event that I wasn't going to paint these, I could and just leave them with the mill scale on. I could just grind down the areas I'm going to weld, probably about 3/4 of an inch above, and this way there's no interference from the mill scale while I'm on it. And so there's the bevel. Just to capture what I was working on, it's these 2" by 3" 45-degree braces, custom order for customer.